Good morning, students. In previous video presentation, I have explained pure substance, mixture, homogeneous and heterogeneous mixture and separation techniques, that is separating funnel, sublimation, evaporation process. Once again, as a part of recapitulation, I am going to explain the previous definitions in the flow chart. First, I am going to explain matter. Matter means the substance which is made up of same kind of particles. Matter can be divided two types. One is pure substance and second one is impure substance. And pure substance can be divided elements and compounds. Elements means it is nothing but pure substance made up of same kind of atoms, whereas compounds, pure substance made up of same kind of molecule. And impure substance and the mixture is the best example of impure substance and can be divided homogeneous mixture and heterogeneous mixture. And solution is the best example of homogeneous mixture, whereas suspension and colloidal particles are belonging to heterogeneous mixture. And the mixture can be classified into two types. One is homogeneous mixture, other one is heterogeneous mixture. In a homogeneous mixture, the components having uniform composition, whereas heterogeneous mixture, the components are having non-uniform composition. Based on properties of these, we can easily focus on true solution, colloidal solution, suspension. And what is the true solution? True solution is nothing but a homogeneous mixture and having solute and solvent. So, whenever sugar is added with water, sugar is solute and water is solvent. Sugar is less in quantity, water is more in quantity. Sugar is dissolved in the medium, water can dissolve the sugar. Now, colloidal solution can be called as heterogeneous mixture, but it appears as homogeneous mixture. And colloidal solution consists of dispersal phase and dispersal medium. What is dispersal phase? Dispersal phase, the particle in a system dispersed throughout medium. Of course, dispersal phase can be called as internal phase. So, why the particles get dispersal? Due to unique charge. Their particles are having unique charge. Due to unique charge, repulsion took place between particles. Where the repulsion took place? In one particular medium. The medium is called dispersal medium. Now the dispersal medium means the component, the medium is nothing but component where the colloidal particles are suspended. Here starch is the dispersal phase and water is the dispersal medium. Of course, if you compare with the homogeneous mixture, if you compare with the true solution, dispersal phase properties almost all compare with the solute and dispersal medium compared with solvent. Once again, dispersal phase means it is nothing but internal phase. Dispersal medium means where the colloidal particles are suspended. Here, colloidal particles size is in between 10 power minus 7 centimeters to 10 power minus 4 centimeters or 1 nanometer to 1000 nanometers. Best example, egg albumin, milk, hemoglobin in the blood. These are the best examples of colloidal solution. In addition to that, colloidal solution can show Tyndall effect. What is Tyndall effect? When our light passing through colloidal particles, here light will be scattered and the path of the light will be visible. Of course, it is called Tyndall effect. I already explained previous. Now the classification of colloidal solution based on appearance. Colloidal solution appears like solid, then it can be called a gel. Whenever colloidal solution appears like solid rigid position, then it can be referred as gel. And some of the colloidal solution appears like fluid, those colloidal solution can be referred as sol. Let us observe some common examples of colloids. So those are dispersal phase, dispersal medium, and type of colloids. Example. The first example, dispersal phase is solid and dispersal medium solid. Then type of colloid or name of colloid is solid sol, and example milky glass. And second one is dispersal phase solid, dispersal medium liquid, and type of colloid is sol, and example mud. And third best example, dispersal phase is solid and dispersal medium is gas, and type of colloid is aerosol, and best example smoke. First, we have to carefully observe the first example, dispersal phase solid and dispersal medium solid, and type of colloidal substance is solid sol, and example is milky glass. See the visuals. Milky glass is the best example of solid sol. Solid sol. Dispersal phase is solid, dispersal medium is solid. And second example, colored gemstone. And let us observe second example, dispersal phase solid, dispersal medium liquid, and the type of colloid or name of the colloidal substance is sol, and example mud, best example of sol. And milk of magnesia, it is also best example of sol. And third one, dispersal phase is solid and dispersal medium is gas, and type of colloidal substance is aerosol, and best example smoke. So these visuals are indicated. Best example of colloidal particles, that is sol. Next, dispersal phase liquid, and first one dispersal medium is solid, and type of the colloidal solution or name of the colloidal solution gel, best example butter. Second one is dispersal phase liquid, dispersal medium liquid, and name of the colloidal substance or type of colloidal substance emulsion, best example face cream. And third one is dispersal phase is liquid, dispersal medium is gas, and type of the colloidal substance is aerosol, and example is fog, cloud. These are the best example. See first example, dispersal phase is liquid and dispersal medium is solid. Now the type of colloid is gel. Here butter is the best example of gel. Now second example, dispersal phase liquid and dispersal medium liquid. The name of colloid is emulsion, and best example face cream. Face cream is the best example. Once again, the face cream is the best example of emulsion. And third one is dispersal phase is a liquid and dispersal medium is gas, and type of the colloidal is aerosol, and best example of fog and clouds. Fog and clouds are the best examples of aerosol. Here dispersal phase is liquid and dispersal medium is gas, and type of the colloidal is aerosol. Now we are going to discuss dispersal phase gas and dispersal. First example, dispersal phase gas and dispersal medium solid, and name of the colloidal solution is a foam, and example rubber and sponge. Second one is dispersal phase is gas and dispersal medium is liquid, type of colloidal solution is foam, and best example saving cream for this phase. Rubber and sponge. These are the best examples of foam. Dispersal phase is gas and dispersal medium is solid. And here foam is type of colloidal solution. And best examples are rubber and sponge. And second example, dispersal phase gas, dispersal medium liquid. And the type of colloidal solution is a foam. And best example saving cream. For saving cream, dispersal phase is gas and dispersal medium is liquid. In previous class, I have explained the separating the components of the mixture. So, three separating process I have introduced. The first one is separating of immiscible liquids. What is immiscible liquids? Two liquids will not mix at single phase. Oil plus water, kerosene plus water is the best example. These immiscible liquids can be separated by separating a funnel. We have already learned in previous video. Now we are going to focus on separating of miscible liquids. What is miscible liquid? Miscible liquids can be mixed at single phase. So these miscible liquids can be separated by one of the process, that is the distillation. What is distillation? It is the process which is used for separation of components of a mixture containing two miscible liquids. Miscible liquids means two liquids can be mixed at single phase. For this separation, which process we are using? Distillation. So for this one, I have taken the mixture, that is acetone and water. How we can separate? First, we have taken acetone and water in a distillation flask. Arrange the apparatus. What we are showing the visuals or images. Heat the mixture slowly and also observe the reading of thermometer. From the observation, first acetone in the mixture vaporizes and condense when it is passing through condenser and be collected from condenser outlet. This is the lab activity distillation process which we can separate miscible liquids. Moreover, the important thing is for distillation process, in a mixture, the components must have sufficient and different boiling points. This is the important for distillation process. Now, I am going to explain another modified distillation, that is nothing but fractional distillation. So, what is fractional distillation? Fractional distillation is the process to separate a mixture of two miscible liquids for which the difference in boiling points is less than 25 Kelvin. For example, I have taken air. Air is consisting of so many gases. Just I have taken oxygen, argon, nitrogen. Its boiling points are minus 180 degrees centigrade for oxygen, argon minus 186 degrees centigrade, and nitrogen minus 196 degrees centigrade. Now, the air is compressed. The air is going to compress. When the air is going to compress, how it will be compressed? By increasing pressure, decreasing heat energy. Then air is changed into liquid air. Further, it allows to warm up slowly in fractional distillation column. Then what happens? Gases can separate it at different heights. For example, oxygen, argon, nitrogen. Among these three gases, and nitrogen is less boiling point. That's why it can condense first, it can be separated first, next argon, and finally liquid oxygen can be settled down. Finally you will get liquid oxygen. So this is the fractional distillation process.